This video shows the RapidMiner progress for the model evaluation and the cross-validation. And here is the process for model evaluation using the training testing method. And it shows you specific operators that we should use and for both regression model and the classification model. For regression model, I use a linear regression model as an example. And for classification model, I use a decision tree as an example. And for both the model evaluation on regression and classification, we'll need to do some data preparation first and using four different operators. And here you can see it's basically the same. And we always start from retrieving the data, and we're gonna need to select a specific attribute. And I still use the insurance data. And for regression model, I select the age, BMI, charges, and the children as input variables, which are all numeric variables. And then I pick the charges as the independent variable or output. So I set the row as label. And for classification model, I did similar thing and I select a different subset of attributes. The BMI, charges, sex, and smoker, because classification is able to take categorical variables. So I can just simply put the sex and smoker here. And for the output variable, I will choose smoker as a output. So basically, that will be the data selection part. And we need to do one more step and to split our data into training and testing. In RapidMiner, you can use the operator called split data. You can simply search split and to see the operator right over here under sampling. And for split data, in our case, we just need two partitions, and one is training, another one is testing. And with a split operator, we can set partitions. So basically, it's a ratio for the partitions. And there is a button, and we can edit the ratios. And if it's the first time you open this panel and it shows the empty ratio, so basically nothing, and you need to manually add entry, use the button here, and to tell the system and what is the ratio for your first partition and second partition. So in my case, I set the first partition as a training data set. So I put the ratio as 80%. And the second partition will be the testing data set. The ratio is going to be 20%. Just to make sure after you add all of them, so the sum should equal to 1. And for decision tree, it's the same setting. So after that, for the split data operator, it's gonna give you two outputs for the two partitions. We use the first partition to train our model. So you can see for both regression and classification, I link the first partition to the actual model operators. So we discussed about model operators in another video, and I'm gonna skip that part. So after that, if you take a look on the model directly, it's going to show you the result. But that's not what we are doing here. And we like to evaluate the model performance on the testing data set. So what we need to do is we need to firstly estimate the output using the model based on the input variables from the testing data set. And then we would like to check the performance. The performance for regression gonna be mean square error, and the performance for classification will be the accuracy rate or prediction accuracy and the computer matrix. So here we're gonna need to use two more operators, one called apply model, and to help us make the estimation on the input values from the testing data set. So we use the apply model, which takes two inputs. One from your actual model operator. So in my regression case, it comes from the linear regression model. So I link the linear regression model with the model input in this apply model operator. And then the second input will be the actual input variables from your testing data set. So that is why I link the second partition from the split data, which is our testing data set, with the apply model. And the apply model operator gonna use all the variables you marked as basic or regular variable, and which is not the label, it's not the output, and it's gonna use all of that and to feed the model to make estimation on your output. And for classification, it's basically the same. I link a decision tree model with the model input, and I link the second partition with a apply model, the second inputs here. And the next thing we need to do is to estimate the performance. RapidMiner provide you several performance operators. If you simply search performance in operator, and you can see that under validation performance predictive, and it shows you several performance. And in the parentheses, it tells you what does it mean, and it's a what kind of performance measure it provides. So in our case, we can simply use the performance regression for the linear regression model and the performance classification for the classification model. So you can see here the performance, I use this performance regression, and it gives you the measures for regression model. We simply use a mean square error. Always here is actually the root mean square error. And for classification model, and we use a performance classification, and we simply check accuracy, and that is it is actually checked by default. And then after that, we would like to see the performance. The performance node is going to give you two outputs, and one is the actual data set. We don't really need to see that. We care more on the performance measure. So we would like to link the first node with the output. After that, we're gonna run the model, and you will see two outputs, and one for here is a result for classification, and it shows you the overall accuracy at 96%, and it shows you the confusion matrix. Because our output is smoker, yes or no, so it shows you the real label and the predicted label, so you can see where the wrong prediction is. And the second tab shows you the root mean square error for regression model. So that is a value you can use directly. So it's around 11,000. And that is the thing we care about. It can help you to measure the performance of your model on the testing data set. And say if you would like to evaluate using the same data set, but on different, for example, classification model, and you can change the classification operator here. Or if you would like to apply it on the same decision tree model, but with different settings, and you can simply change the parameters and just to see the change of the performance. So that is a first one, using the training testing method and to do the model evaluation. RapidMiner also provides you have another process and showing you the operator of cross-validation. So RapidMiner also provides you the cross-validation method that you can simply search and the operator search for cross-validation. And that is one operator under the validation folder here. And for the cross-validation, and you can see the operator looks a little bit different than the regular operator. So here it seems like it has two tabs, so like two pieces of paper. And that means in RapidMiner, that means it has a sub process. So for the regular operator, when you click that, you can change your setting in the parameter, and that's it. And for those sub progress, and you can double click this operator, and it's gonna show you the sub progress and for cross validation. And basically it has two training and testing, two stages. So let's come back and take a look on the data preparation first. In this progress, I show you two, again, the same cross-validation for regression is the first part, and the cross-validation for classification is the second part. For the data preparation part, it's basically the same. For the first three steps, we retrieve data and select our attribute and set our output variable. That's it. But because we're using cross-validation, we don't need to split our data. So we basically skip this fourth step. And we simply link the sample set directly to the cross-validation. And then we need to make some changes inside the cross-validation sub-progress. So we can double-click that and go inside this progress. And then in the progress, and depends on what model you use, and you need to put the model operator in the training set. So for the first one, I put a linear regression. For the second one, I put a classification model here. And then for the testing side, we use the same two operators. We use the apply model and we use the performance. And for regression and for classification. You just need to link the nodes together and that will be it. So at the end, again, we care about the performance. So we need to link the performance with the output of this sub-progress. So I can show you the classification, basically the same. So I just use a different classification model operator and choose a different performance on classification. So at the end, the output of the cross-validation will show you the model and the performance. Here, I just show you the model and in order to show you how it looks like, but it basically it's the same, it's the output of the model. And then for the performance, it looks the same. It can calculate the overall performance based on the average based on how many times or how many faults you want the cross-validation to do. And it gonna do that for you. And at the end, it gonna calculate the average, either average mean square error or average accuracy rate for you. So at the end, you will see, again, a similar, just a one value as the output. And one last thing you can set for cross-validation is how many faults you want. By default, it's gonna be 10. And you can choose to increase or decrease the number. Oh, if your data set is not too large, you can choose to click and leave one out and to make it leave one out cross-validation. At the end, we can run the model and you will see that looks similar. And then the performance for classification, it shows you the accuracy and the confusion matrix. The performance of regression, it shows you the root mean square error. It gives you a small range after the value. It's mainly because we care about the average, but because you have multiple faults, so it runs the model multiple times and it will get multiple like accuracy rate or mean square error. So at the end, you will get a series of values with a range. And it shows you the average, but it also shows you the range. And what is the range of this measure? So accuracy rate or root mean square error. So here you can see the range as well. So basically that is, again, the two values that we care about, we would like to see, and to help us to evaluate the model. And if you would like to change your model, you need to double click this cross-validation sub-progress and modify this model operator here. And again, just remember to adjust your performance operator if you choose to not using classification, but use a regression, so you need to modify this part. So that is this recording all that about, and basically about the model evaluation using the training testing dataset and also using the cross-validation operators.